So we simply continue and look at the valence of radicals. So we must ask ourselves, what exactly is a radical? So when we talk about a radical, we can simply say a radical is simply a group of atoms present in several compounds, but they cannot exist on their own. So we can say a radical is a group. So we can simply say is a group of atoms present in several compounds, but incapable. So when we use the word incapable, we mean they are unable to exist on their own. So incapable of independent existence. So that is what we simply call as being a radical. So it's a group of atoms, that's the key word, that can be present in several compounds, but they cannot exist on their own. And this is what we are simply calling as being radicals. Now, how do you determine the valency of a radical? Well, I want you to take note of the point that when it comes to radicals, for you to determine the valence of radicals and ions, when it comes to radicals and ions, the valence is simply the value of the charge on the ion. So we can simply say you consider the valency is the value of the charge on the ion. So this is what we are talking about, and that's what we call. So for those radicals and ions, the valence is simply the value of the charge on the ion. For example, you might have actually seen an element that has maybe NH4 plus. In this case, this is what we are calling as being a radical, because it has a group of atoms that are existing together, and you can see the charge that is there. It's a positive charge that is there, so that simply tells you that it has a valence of 1. But let me give you some common radicals, their formula, and you get to know the valency. And this is what you need to know. Remember, knowing the valences of elements and radicals will help you to write the chemical formulas. Without knowing the valences, then it will become very difficult for you to write chemical formulas and hence to balance them. So I want to give you a few examples of some common radicals that we do have. So one, we can simply talk about what we call as being nitrate with the formula NO3. In this case, all these are having a valence of 1 that I'm writing. You can also have nitrite, nitrite, in this case, capital N, capital O, and a 2. That's what you need to remember. You can also talk about what we call as being hydroxide. So we can also talk about hydroxide, that's capital O and capital H. They have a valence of 1. We can also talk about what we are calling as being ammonium, in this case, which is capital N, capital H, and the subscript at the bottom there, which is a 4. You can also talk about what we call as being chlorate. So when we talk about chlorate, it's capital C, small l, capital O, and a 3 there. So that is chlorate there. So that is L. We can also talk about maybe what we call as being hydrogen carbonate. So hydrogen carbonate. You can also talk about hydrogen sulfate. Yeah, so this is what we are talking about. So if you look at all these are radicals. You can see they exist in 2 or more atoms are actually coming together, and that is what is forming up what we are calling as being a radical. So you need to know radicals. On the periodic table, you will not find any radicals, and hence as a student, it is prudent on your part to know the radicals, the correct formula that you use, and know that these belong to, they have a valence of 1, because that is what you are going to be remembering. So get to know the radicals, the proper formulas, and the valency, because you are going to use them later on. Then there are those, radicals that have a valence of 2. For example, the common one that we can talk about is carbonate. Yeah, capital C, capital O, and the 3 at the bottom, a subscript there. Sometimes, of course, when I talk about oxygen, when it has reacted, it forms up an oxide. So this is when oxygen has reacted, it forms up an oxide. Of course, that is not basically, we can say, a radical, but that's a capital O. That is what you're going to be finding. That is just basically oxygen. But maybe the common one that I can talk about is sulfate. Sulfate, capital S, capital O, and a 4 at the bottom there. So this is what we call as being, sulfate. You can also have what we call as being sulfite or sulfite. In this case, SO3. It is less of 1 oxygen. All these actually have, a valency of what we are calling as being a valency of 2. And there may be the last but not the least, those that are having a valence of 3. The common one that we do have is what we call as being phosphate. Yeah, so you can actually have what we simply call as being phosphate. Capital P, capital O, and a small 4 there. So that guy has simply, a valency of 3. So this is what you need to know, get to know, in this case, the valences of radicals. So like I said, for radicals and ions, valence is the value of the charge on the ion. So in most cases, you are going to find that, when these formulas have been written, for example, nitrate, NO3, you may find a negative there. So that negative tells you that it has a valence of 1. Nitrite, we may also write it like that. But remember, we are not interested in those charges. We are interested in the number, because that is the valency. Hydroxide, it may have, OH and the minus there. That simply tells you it has a negative 1. Ammonia, you may find it NH4 positive. That positive tells you it has still a valence of 1. That positive or negative is just telling you about the charge. The same may apply to this one. When we talk about a chloride, it may just have a negative. This one and may have those things that we are talking about. Carbonate, you may find that it may be written CO3, a 2 minus. Oxygen may be written as a 2 minus. Sulfate may be written as a 2 minus. Remember, those negatives are simply indicating the charges, but what we're interested in when we're dealing with valences are simply the numbers. That's what we're interested in. Phosphate, PO4 may be written 3 minus. We're interested in the 3 there. That negative just tells you about the charge of the radical. Thank you so much for watching. Please watch out for some more so that you can actually get to benefit now how we write chemical formulas in chemistry. Thank you for watching.